Hey guys, this is going to be part 3 of the Custom Asset Editors tutorial series. And if you remember in the last tutorials, I showed you how to create your own custom assets within the editor. You can open them up and make a graph. So in this tutorial, you can already see that there's a new type of node here called Start. So I'm going to show you how to make multiple different kinds of nodes. And if I right click, I can make two of the new types. So we have a dialog node here and an end node. And so basically we're going to extend the previous tutorials to make a dialog tree system where we can create dialog trees in the editor. And that'll include how to edit the data of individual nodes. So you can see the dialog node info panel coming up here where I can enter whatever I want and it'll show up in the title. And I can even add new pins here. If I change this dialog responses array, I can add new options for output. And we still have the old functionality where I can add these manually as well, and you can see the dialog responses increment on the right. And just like last time, you can make new nodes, you can link them together. And we're going to use this functionality to create a full dialog tree. So I have one already created here where we have some reasonable dialogue, and each one of the blue nodes is where the dialogue ends. And we even have a feature where you can select what happens at the end. So in this case, we have a start quest action ID, and we can include the quest name that we want to start. And then the very last thing in the tutorial is I'm going to show you how to actually use this in game. So if I start my game here, you can see a dialogue comes up that's based on that tree we just looked at. You can see the text gets displayed in the middle and the options get filled out as buttons on the right here. And so you can make responses here and we'll walk the tree. At any time I can hit no and it will close it. And that no basically just corresponds to these end nodes. And I can go all the way through the tree. And when I'm done, you can see it starts a new quest, beginning business, and that depends on which end node I hit. If I go the other way on the tree, then I get beginning adventure instead. So I'm pretty excited about this tutorial. Let's get started. By the way, if you missed the previous two videos, I'll link those two in the description. If you don't want to watch all the way through those two, you can copy paste the code from the GitHub repository in the last video and start from there. To get started, I have the same project we ended with last time, where on the left I have our custom asset editor plugin with all of that source code inside it. And so the first thing I want to do is rename this to DialogAsset editor. And the reason is just so that all the names make more sense, since we're actually going to use this to do something useful now, which is to make a dialog tree. And so I'm going to right click, and there's this really cool extension called Rename Replace that you can get on the extensions marketplace for VS Code. It's free. If we click on that, I can just replace all instances of custom with dialog. And the cool thing about this is it's going to rename files and folders. And if you had a more complicated rename, it would actually match the common coding casings like Pascal case and camel case or all uppercase. And it would replace all those as well. And you can choose which ones you want to enable, but it makes refactoring really cool or really easy. And so I'm going to click rename here. And you'll notice on the left, we now have dialog asset editor. And if we go into source, everything is renamed to dialog instead, the files, and if I open them, even the file names are renamed as well. And so if you don't want to do that, just wherever it says dialog later in this tutorial, replace with custom instead. But that's how you do that. And you can use any tool you want to do this rename as well. If you don't have VS Code, there might even be a similar extension for Visual Studio. But we do need to do one more thing. If we go to tutorial project and the build file, we need to just change these to dialog as well as the last thing. And now if we just build and run, we should have the exact same project, but with dialog assets instead of custom assets. And that worked just fine. And you can see if I right click now, instead of custom assets, it says dialog assets and my dialog asset instead, but everything else is the same. All right, so the next feature we want to add is the ability to edit the data on any selected node. And so we want to share this data between runtime and the editor. So we're going to create a shared class in the dialog asset editor runtime folder. So I'm going to do new file and we'll call this dialog node info.h. And after adding all the boilerplate, we're just going to have 3 properties basically. So we're going to have edit anywhere property called fTextTitle. And this will be an optional title for the node if you wanted to give them some kind of specific naming convention or something like that that didn't include the actual text. And we're going to have another one called dialog text. This will be what it actually displays when the dialog comes up. And we'll have one more. And this will be an array of the responses that the user can make to this dialog prompt. So we'll call that dialog responses. And then we're going to go into dialog runtime graph, which is the runtime version of everything that gets saved in the asset. And right in the dialog runtime node, we're going to attach this new data to it. So I'm going to do uProperty, uDialog node info, and we'll just initialize that to null pointer by default. And we also need to include it up here. So include dialog node info.h. And while we're here, I'm going to go to DialogAsset, and we just had a bunch of dummy data in here. So let's make this real data. So I'm going to delete some of those dummy properties, and we'll just have a dialog name. And just initialize it to enter dialog name here. So people will know to change it when they open this asset. So then we're going to go back to our plugin, and we're going to open our dialog graph node. And let's see, so we want to do a few things here. So we're going to have a little bit more of a complicated node title later. So let's move that into the CPP file to start. And before we do that, we're going to add our node info to the header file here. So I'm just going to do void set node info, and we'll forward declare the class uDialog node info. And we'll set a member variable we'll make in a second, node info equals node info. And we'll have a getter as well. So class uDialog node info, get node info, and we'll return that member. And then we need to declare that member down here. So actually, this can be public, and our member will be private. So make a property, class uDialog node info, and we'll make sure that's initialized to null pointer as well. And then, like I mentioned, we're going to go into dialoggraphnode.cpp, and at the top here, we're going to implement the node, that node title method. So ftext uDialogGraphNode get node title, and that takes an enode title type. And we'll just have the similar implementation from before, except this time we're going to use our node info. And for the moment, let's just return the title. We'll make that slightly more complicated later. And we need to include the node info class, so dialog node info.h, because we forward declared it in the header file. And this does still need to be labeled as constant, and in the header file, I think I took out the override. So this is const override. So now in the schema, if we go to dialog graph schema, this is where we're creating new nodes. So we need to initialize that data. And so right below where we set the position of this node, we're in the fNewNodeAction perform action, which again gets called when you right-click the context menu and click create node. We're going to set results, set node info, and we'll make a new object, uDialog node info. And the parent, we'll just parent it to the node for now. I'll talk more about this later, but this parent actually matters. And if I'm using node info, I need to include it at the top. So include dialog node info.h, and that's all we need to do there. But we do need to go to our app, and in update editor graph from working asset, we need to set the info on this node. So this gets called when we are loading our graph. So basically when you open up an asset, we're filling out what the graph nodes should be based on the saved data. And so for the new data we're adding, we're going to say if runtime node info is not equal to null pointer, we're going to set it. So set node info. And I'm going to call duplicate object. And this is because we parented it to the node. So when the node goes away, the object can go away, and so we need to basically give it the working asset as the parent instead. You can also do this by, if you were to override the graph type, you could put the working asset we're working on there and use that as the parent, but it's easy just to duplicate it, and it has to be duplicatable anyway because we're saving it as a UObject to a file, and so anything that's not marked as a U property isn't going to get saved anyway. So this is safe enough, and we're going to do runtime node, oops, node info, and we'll give it the node as the parent. And if the node info is not null, then we're going to make one. So unode set node info, uObject, uDialog node info, runtime node. All right, so this is when we're updating the graph from the working asset. We have to go the other way as well. So if we go to update working asset from graph, this is when we're going to update the working asset just before saving. And so we also need to set the info as well on our runtime node. And so we just have a generic pointer to uEditor graph node, the parent class of our custom node class. So first we got to get our custom node class. So we're going to do uDialog graph node, UI graph node, and we're going to cast the parent to a uDialog graph node. And so now we can access that data. And I am going to check if UI graph node is null. And we're just going to continue. And then right below where we set the runtime node's position, we're going to set its data. So node info equals UI graph node get node info. All right, and once again, the reason we're doing this is so we can share the exact same data class between our runtime and our graph or our editor time data structures. And so that way you don't have to rewrite all the stuff between the two different things and minimize the amount of copy pasting essentially. So while we're in the app, there's a few other things we want to do. So we're going to go to the header file. So DialogAsset editor app.h. And we're going to need a few methods in here. So right below rather, get working graph, let's add a few more methods. So we want a set working graph UI, and I'm going to give it a tshared pointer to an sgraph editor. And this is the slate graph that is hosting the logical uEditor graph. So this is the UI, this is the data essentially. But we're going to need to know when this changes because we want to be able to edit the data that we just added when you select the node. And so we're going to use this in order to get access to the selection. And so we need the app to be able to know what that is. And because we create it with a tab factory, we need the tab factory to be able to set it on the application. And so that's the purpose of this setter. And we'll make this member in a second, but we'll say working graph UI equals working graph UI. And then down here, we'll set what that is. So we'll say uProperty. Actually, it doesn't need to be uProperty because it's a shared pointer. So we'll just do tshared pointer to our sgraph editor. Working graph UI equals null pointer. And once again, this is the working graph UI, which is the slate widget. Okay. And then we're going to need a few other things up here as well. So we're going to need set selected node detail view. And that's going to be another shared pointer. And we'll forward declare this one. This will be a pointer to an iDetails view. And this will be the view that actually edits the data. And we'll do that in the CPP file. But we will need to declare a member for it over here. So we'll just do tshared pointer. Again, forward declare iDetails view. And we'll call that selected node detail view. And initialize it to null pointer. And lastly, we need a function whenever the graph changes. So we basically want to sync this two ways. Whenever the graph changes, we want to update the properties view. And whenever the properties view changes, we want to update the whatever the selected node in the graph is. So we're gonna need one more function on graph selection changed. And it takes an fgraph panel selection set. And we're also going to need to include sgraph editor up here. So found include or graph panel rather, sgraph panel.h. And I guess while we're here, we're also going to need, I mentioned there's going to be two-way syncing. We're going to need a function for on node detail view properties updated. And this takes an fProperty changed event. And that should be everything. So just to recap real quick, we have our graph model here. And this is the working graph model. So this is not the UI, it just contains the data. And then we have the sgraph editor. This is the slate widget that displays this graph. And so now the app will know about both of them. And then we created a couple of setters here so that the tab managers can tell the app what the widget it created was for the graph editor. And likewise, we can have the properties tab manager, or tab factory rather, tell the app what the details view it created was. So it'll call these two later. And then we're going to need an onGraph changed method so that when you change the graphic and update the selected node, and when you, sorry, where's the other one? Sorry, when you update the properties, on node detail view properties updated will get called. And so now we'll go to the CPP file and actually update these or set what these are. And I think I also forgot to include the node info class. So at the top, I'm going to do, include dialog node info, which will be needed when we build later. Now we can implement some of those methods we created in the header file. So first one we'll do is DialogAsset editor app on node detail view properties updated. And that took a fProperty changed event as its event. So in here, we just want to let the UI know that it changed. So we're going to call if working graph UI. This is the slate widget that we just created. If that's not null pointer and the properties updated, we want to notify that the graph needs to update as well. So basically when you change the data, the graph needs to redraw the nodes. And so this will make sure that that happens. So notify graph changed. And if I go back to the header file, we also need to implement this set selected nodes detail view. And so we'll go down to the bottom and we'll implement that one. And that's also DialogAsset editor app. And so in here, we're just going to set the selected node detail view that we created in the header with the one that's passed in. And the reason I'm implementing it in the CPP file here is we also want to call a function. So we want to call on finished changing properties. And we want to add a callback to it. So this is a delegate. And we're going to add a raw function to the delegate. And this is the other function that we created in the header DialogAsset editor app on node detail view properties changed or updated rather. And so this will link whenever our detail view changes properties, it's going to call on node detail view properties updated, which is that other method we created here. And lastly, we need to implement when the selection change. So we have this on graph selection changed thing in the header that we made. We have to implement that. And this is going to get called whenever the selection changes, and we'll hook up the delegate in the tab factories, but we'll just implement it here for the moment. So DialogAsset editor app. And the selection that gets passed in is just a group of view objects that are selected. So we just want to find the first uDialog graph node in that selection, if there is one. And so we'll just iterate over this. So view object, object, oops. So for each object in that selection, we're going to check if it's a node. So uDialog graph node, node equals cast, uDialog graph node object. And if that's not null, then we're going to set this as a selected object. So selected node detail view, set object, node get node info. And then once that's done, we can return. We'll only support selecting one node at a time, although you could actually set multiple objects on this, and I believe it'll set the common set of properties instead. But if nothing's selected, then we'll get here, and we want to say selected node detail view set object to null pointer. And there we go. So this is all ready to get hooked up to the selection change listener. And so now we want to go to the tab factories and we'll implement the changes there too. So let's start with the DialogAsset properties tab factory. And if you remember, we have a create tab body function here, and we're just going to want to modify this a little bit. Let's start with making the new details view. So we already have one for the overall graph properties, which is right here. So let's make another one. So I'm going to make t-shared pointer details view, and we'll call it selected node details view. And we can use the exact same function, property editor module, create detail view. And we can give it the same arguments. And let's just initialize the object on it. So selected node details view, that object. And we'll set it to null pointer. And now we'll use that method we just created on the application to set the selected node details view so that it has that pointer. Okay. And then we already have the existing details view for the overall graph settings. So we're just going to copy and paste this slot basically. Oops. So we'll make another slot, and right below it, they'll both have a fill height of 1, so they'll both take 50% of the height. And so instead of this details view, we'll give it the new one that we just created. And then likewise, so this was the properties tab on the right. So if we go to the primary tab factory, which actually creates the graph, we're going to do a similar thing here where we want to, we still want to do this snew. So let's move that up here. But instead, we're going to make a pointer to it. So t-shared pointer sgraph editor equals, and then we're going to paste the snew graph editor. So this is what this is one of the members that we added to the application, and so we're just going to remember it here. We also want to, while we're doing this, give it some events. So hang on, let me just finish what I was doing here. So we're going to create the graph editor as a pointer now, and then we can pass that in down here and do t-shared ref instead. And then we can set this pointer on the app. So app set working graph UI, I think we called it. Set that to the graph editor. And so now the app has a pointer to the graph editor as well. But we want to do one more thing, which is we want to be notified when the selection changes, which is the whole reason we're doing any of this. And so I'm going to make what's called a sgraph editor, fgraph editor events. And we'll just make a local variable called graph events. And if I look at this fgraph editor events, this is all the events that you can subscribe to for the graph. We're interested in on selection change, but you can see if you wanted to do anything else, there's a whole bunch of other ones, like when it's focused, when something's double clicked. So if any of the other things here look useful to you, you can add a handler for that as well. But all we care about right now is selection. So we're going to do graph events dot on selection changed dot bind raw. We're going to get our app pointer, and the function we're going to bind it to is dialog asset editor app on graph selection changed. And so this will hook up the selection event to the app method that we made on graph selection changed. This will look through the current selection. It'll pull out whatever the whatever dialog graph node is selected, or whatever the first one is in the selection. And it's going to set the info that we created on that object to the detail view. And so you'll be able to modify our node info class from the detail view. And when the detail view changes something, it's going to call onFinished changing properties, which we bound to the other method onNode detail view properties updated. And this is going to tell the graph that it changed, and it will update it from there. And so that's how everything works. And let me just do a quick check. Looks like I have a couple typos here. This should be first. And actually, if I go back to the properties tabs factory, I think I forgot to include our new dialog info type. So include dialog node info.h. And actually, in primary tab factory, I never we created the graph events local variable, but I never actually set it on our graph editor. So let's do that real quick. So .graph events, give it the graph events. And there we go. We should now be able to edit the details on our nodes. Let's build and run and see. And that builds. So if we right click and create a dialog asset, I can open that up. I can right click and create one of our nodes. And right away you can see on the right here, dialog node info pops up. And I can change the text in here. I'll change the title. And you can see the title shows up right away as well. There's a few things I don't like about this. First, you'll notice that if we don't have a title and I enter some dialog text, this dialog text gets saved to this node, but it'd be nice if you didn't have to have a title. That was sort of an optional thing. And so first we want to basically make the first part of the dialog text be the title if no title is assigned. And the other thing is, if I add dialog responses here on the right, you'll notice that once again, the data saved. If I select the node, it comes back up, but we really want the output links here to reflect what's in the dialog responses. And then there's just some other cleanup we'd like to do, like some input. We could change that to be, display. And once again, we'd like these outputs to be synced with the dialog responses. So let's go back to the code, and we don't need to save that. And first thing we're going to do is go to dialog graph node once again. And in here, we want to add a function called, well, first of all, let's start to organize this a little bit better. So this will be a section for our interface, whereas this up here is the uEditor graph node interface. And right below here, we're going to add a new function, and we're going to call it sync pins with responses. And so we're going to call this method when we want to sync our pins with the responses that are in this node info class. So we can go to the CPP file for dialog graph node, and we'll scroll all the way down to the bottom and implement that new method. And so we're going to make an assumption here that the first pin is always going to be the input pin. So first let's start by getting our info. So dialog node info equals get node info. Oops. And let's see, the first thing we need is the graph node pins. So the number of graph node pins, and that's going to be our current pin count minus 1, because we're assuming the first one is the input pin. And we need the number of info pins, and that's going to be node info dialog responses.num. So that's just the number of output pins that we have. And so first we're going to do while num graph node pins is greater than the number of info pins. And we're going to remove pin at num graph node pins minus 1. So basically remove the last one and make sure that it is an output pin. So editor graph pin direction egpd output. And we're going to decrement num graph node pins by 1. So we're going to make sure that the number of pins we have is the same as the number of the output pins, or sorry, the number of info pins. And then we're going to go the other way as well. So while the number of info pins is greater than number of graph node pins. So if we ever have more info pins than graph node pins, we're going to create a new dialog pin. And so, sorry, I think I worded that that wrong for this one. We're going to create graph node pins if we have more info pins. So create dialog pin, editor graph pin direction, gpd output. And the name is going to be the node info, dialog responses at num graph node pins, since that's the last index we just created. And we'll do toString. So create a new pin, and then we can increment our count. So num graph node pins plus plus. And so we'll basically add new pins until the amount that is in our dialog response array is the same. And then lastly, we need to sync the text. So we'll do int index equals 1, or const ftext option node info dialog responses. So for each option in our node info, we're going to get the pin. So get pin at index. And we started it at 1 because we're assuming that the first one is the input. So get pin at index. And we're going to set the pin name to fname option.toString and increment the index. So lastly, we're going to, if we have more pins on our node than we have in our info, we remove them until we don't. And if we have more pins in our info than we have on the graph node, we're going to create them until we don't. And then we're going to synchronize the text for each pin with our dialog response text. And that should sync all the pins for us. And we also want to clean up some of the other stuff in here. So I mentioned before, if we don't have a title, it'd be nice if it just showed the first part of the text. So let's do that. So if node info title is empty, so if we don't have a title, then fstring dialog text string equals node info dialog text dot toString. And if the dialog text string dot length is over, let's say 15 characters, then we're going to truncate it. So we're going to set dialog text string equals dialog text string dot left. And we'll set it to the leftmost 15 characters, and we'll just add an ellipsis at the end to make it look nice. And then we'll return ftext from string dialog text string. All right, so if we have no title, we're going to get the string, or we're going to get the dialog text instead. And if it's greater than 15, we're just going to truncate it to 15 dot dot dot. And then we'll return that instead of the title. And then in the context menu actions, previously we had add pin. We can rename that to add response and creates new response instead. I guess that can be lowercase. And likewise in delete, we can just put deletes response, deletes the last response. And now that we have our sync function, instead of creating a dialog pin, we actually don't want to do that anymore. Instead, we want to get the node info. So node get node info. And we want to get the dialog responses. And we're just going to add one. So ftext from string text. And we'll just have it be called response by default. The user can change it right away. And now that we added to the dialog responses, we can just call our sync function. So sync pins with responses. And so instead of having to add one manually, we'll just add one to our array and sync instead. And similarly, down in the delete function, instead of removing the pin directly, instead we're going to get the info. So you dialog node info equals get node info. And then we're going to do info dialog responses dot remove at. And we just want to remove the last one. So info dialog responses dot num -1. So remove the last one. And then once again, we can just call our sync method. So node sync pins with responses. And I think that's all we need to do in Dialog Graph node. There's a few other cleanup things we want to do. So if we go to the schema down here in perform action. So previously we'd created 2 default outputs, and we actually don't really want to do this anymore. So instead we're going to delete this, and let's see, we'll just have a default response be continue, and we'll do result create dialog pin editor graph pin direction egpd output fname, and we'll give it that default response. And we need to add the corresponding one to get node info, dialog responses, dot add, and then ftext from string default response. Okay, and I suppose we could have used our sync function here as well, but whatever, that should work. And so now that we have a sync function, we need to go back to our app. And if I go to the header file, basically what we want to happen is whenever we change the responses on the details view on the right, we want to update the node to reflect that. And so we need to know when the selection changes once again and be able to get that selected node. So first thing I'm going to do is just make another helper method here under our protected section. And I'm going to say class uDialog graph node get selected node. And we are going to give it the selection. So graph panel selection set. And if you remember, this was the same thing that we had in our on graph selection change. So we're actually going to use the same code here, but we're going to move it to a helper method so we can get at it later. And now if I go back to the app code, right above set selected node detail view, I'm going to add the function we just made. And we don't need to forward declare that, but we do need to implement it. And in here, we're basically going to do the same thing that we did when the selection changed, where we want to find the first graph node. So let me just copy paste that, and we'll give it a function comment instead. So we want this to return the first uDialog graph node in the given selection. And we want to return null pointer if there are none. So basically, once again, it's going to do the same thing this did, but we're going to use the function instead. So basically assume the function's written already. So down here, we're going to say uDialog graph node selected node equals get selected node and give it the selection. And if selected node is not equal to null pointer, then selected node detail view set object selected node get node info. So same thing we did before, except using the function, and otherwise we'll just set this to null instead. So then back in our get selected node method up here, so once again we're going to iterate over the selection. We're going to see if it's a graph node. If it is a graph node, then instead of setting this directly, we're just going to return it. So return node. And then if we didn't find one, we'll get here and we'll just return null pointer instead. So now we have a get selected node method that we can use, and we're going to need that for syncing our pins. So now if I go back up to on node details properties updated, or on node detail view properties updated rather. Once again, we're going to get the node being modified. So uDialog graph node dialog node equals get selected node. And we're going to use that working graph UI member we got before to get the current selection. So get selected nodes. And if dialog node is not equal to null, then dialog node sync pins with responses. So we'll call that sync method that we made. And that should keep our pins up to date. Now, one thing I did notice is that onGraphChange doesn't actually get called when you link pins together, which is a problem for keeping things up to date. And so I do want to make one more change. So if I go to DialogAsset, UObjects have a method called presave that we can override. And I'm going to add a void method called set presave listener. And this is going to take a function and it'll just return void with no parameters. And we'll call this on presave listener. And we're going to have a member called on presave listener equals on presave listener. And then down in our private members, we're going to define that. So std function void on presave listener. And we'll just initialize it to null pointer to start. And we also need to include functional at the top as well. And so in the UObject interface, so UObject interface, it has a method virtual void presave. And this gets called right before UObjects are saved. And since this dialog asset, whenever it saves, we want to update all of its contents with the current graph editor contents. Instead of relying on graph changed, we're going to rely on presave, which should be a lot more reliable. And basically, whenever anything changes, it should call this. And so f object presave context. And we're going to override that. And then in the CPP file, dialogasset.cpp, we actually haven't used this yet. We're going to implement this method. So DialogAsset presave. And if we have a presave listener on presave listener, then we're going to call it on presave listener. And we do need to include something uObject/object save context .h because this is actually not defined in the header file. So we'll include that. And now we want to go back to our editor app. So dialog editor app.cpp. And we want to do a few things here. First of all, in init editor, at the end, we had this graph change listener handle. We want to get rid of that, and we'll get rid of the graph change listener handle in the header file as well. And then back in the CPP file, we instead want to use the new one. So right below, when we get our working asset, we also want to set presave listener that we just created. And we can just create a lambda. And all we want to do is call a new function we're going to create called on working asset presave. And then in on close, instead of removing our graph change handler because we don't have it anymore, we're going to do working asset set presave listener. And oops, set that to null pointer. Now this won't support multiple editors changing the asset simultaneously this way, but you probably don't want to support that anyway, so this should work fine. And then instead of the old onGraphChanged method, we're just going to rename this to onWorkingAssetPresave. And we're going to have to define that in the header file as well. And once again, instead of this onGraphChanged method, we'll do onWorkingAssetPresave instead. And so now if we go back to our CPP file, once again, this is just going to update our asset from the graph just before, just before saving it. And let me just do a quick check for typos. Looks like I missed a semicolon here. And I missed a wap here. And actually, I think in the schema, oh no, sorry, in graph node, right up at the top, I had a typo here. This should be dialog text string. And I mentioned earlier we wanted the sum input to just say display instead, because that would make more sense. So this is the input pin on our nodes. So they'll make a little bit more sense now as well. And I also, if we go back to DialogAsset, I had a typo here as well. And I'm sorry, just one more in dialog graph node. And at the bottom here, I misspelled index. And that should work now. So let's test out. The pins should sync properly now. And when you change the object, it should also call our pre-save listener. All right, so that built and ran just fine. So once again, we can create a new asset. We'll open that up. And we can create a node. You can see our input pin now says display, and the outputs continue. And you can see on the right here under dialog responses, this is properly synchronized. And if I create a new one, you see it creates an out pin over here. And so let's say we wanted our options to be yes, no. I can enter it in. You see that it creates it over here. And another thing we added is if there's no title, if I just say like greetings, traveler, whatever, see the first 15 characters are displayed as the title now. So that should make it really easy to kind of chain things together now and make, or at least start the makings of a dialogue tree. So you can say yo or whatever over here. One problem with this is it's not clear where the graph actually starts. So we could just say that if you have a node that doesn't have any inputs, that's the start. That'd be one way to do it. But it would be nice to have an actual start node that indicates where the graph kicks off from, and everything has to start from there. This will also get into how to create multiple different types of nodes and have different looks for each one as well. So let's go ahead and create a start node. So the first thing we want to do is go to our runtime graph here, and somewhere at the top, we can create an enumeration. So we can go enum, and we'll do enum class dialog, dialog node type. And we'll have three things here. First one will be start node, we'll have dialog node, and we'll have end node. And so we're going to use this enumeration to identify what type of runtime node each one is. And so this will be the new one that we're going to create right now. Dialog nodes will be the one that we already have that you can set title and text on, or different output pins. And then end node will be the last one we create. Won't do it yet. We're just going to start with start node for now. So we can copy and paste that and go down to our dialog runtime node class. And under public here, above input pin, we're just going to do edialog node type, and we'll just default it to dialog node, the one we already have, and that has to be a property. And fix the spacing. And now we actually need to create that. So back in our plugin, or our DialogAsset editor plugin, I'm going to make a new file and we're going to call it dialog start graph node.h. And we're actually going to need another file called dialog graph node base. So new file, dialog graph node base. And this is going to be the base class. So we're going to have two nodes. We're going to have dialog start graph node and dialog graph node. And both will inherit from this base class. So let's implement the base class first. And we're going to make the class called dialog graph node base, and it will extend from editor graph node, just like our existing node does. And our interface is going to be virtual editor graph pin, create dialog pin, and then we'll give it the pin direction, editor graph pin direction, and we'll give it a name. And then we're actually going to grab this from the existing graph node class. So we already had this So this will just override the base class one now. So override that. And we're actually going to move the dialog info stuff to the base class, and this will inherit from dialog graph node base now instead, and we need to include it. So we'll go back to the base class, we'll paste the node info stuff here. And now in the base class, create dialog pin, we're going to have two different versions of this, one for the start node and one for the regular dialog graph node. And so just put a comment here, must be overridden. And if it's not, it'll just return null pointer. And now in our new node, dialog start graph node.h, and we'll call this class u dialog start graph node, and it will extend from that base class. So u dialog graph node base. We're going to have a very similar interface to our existing node. So we still want node title, node color, and can user delete node. So we'll copy those. And for the moment, the title will just return ftext from string start. And that's probably all we need for that. And instead of green, let's just do red. Why not? And for can user delete node, we don't want you to be able to delete the start node. So we're going to return false for that. And then for, oh, excuse me, this is the editor graph node interface. And then for our base class interface, we're just going to have that create dialog pin method. So let's just copy paste that from the base class. And we're going to override that and implement it in a CPP method. So let's make the CPP file. So dialog start graph node.cpp. And we're going to include the header dialog start graph node.h. And we want a very similar version to the one that exists already in the existing dialog graph node.cpp. So if we go there, we can just start from this one and copy paste it into here. We'll change the class name to u dialog start graph node. And then for category, for start nodes, this will always be outputs. It'll only have one output pin. And for subcategory, we're going to say start pin, and we're going to use this to decide the color of the pins later in our dialog pin factory. Other than that, this can all stay the same. Now, speaking of this subcategory, if we go to our DialogAsset editor.cpp, and near the top, if you remember from last tutorial, we have our sdialog graph pin here, and we have our pin factory. We want to change this so that the start pins look a little bit different than the regular dialog output pins. And if you remember, we were checking the subcategory to decide which one to use. And so what we want to do is just make a new pin type. So I can copy paste that one. So instead of sdialog graph pin, we'll just do sdialog start graph pin. And then everything else can stay the same. And then we'll just change the color. So instead of green, it'll be some shade of red. So I'll just do 1.2.2 should be fine. And then in our factory, we just need to return the correct one, depending on what the subcategory is. So we'll just add an else if on that for if the text is start pin instead of dialog pin in that subcategory that we set. And then we'll return this sdialog start graph pin instead. And so this will make the start pins or the output pins on the start node look different. And so you can configure this however you want it to look. But we're going to go to the DialogAsset Editor app now, and we can actually start to use our new start node. And so at the top here, I'm just going to include it. So include dialog start graph node.h. And while we're up here, we're going to need to log errors and stuff. So let's define a log category. So define log category static and dialog asset editor at sub log all. Okay. And then let's go down to update working asset from graph. And then, so we added this UI graph node check before. We're actually going to move this. So let's delete those. And same thing, we were setting the info on our runtime nodes here as well. I'm going to move that down as well. And so we'll go down to just before we add the node to the runtime graph. And we're going to say if the UI node, and we'll check the type, is a uDialog graph node, then we're going to do the cast that we did above here. So uDialog graph node, UI graph node. And now we're going to set the node type. So runtime node, node type. And we'll set it to eDialog node type, dialog node. And then runtime node, node info. Oops. And here we'll say UI graph node, get node info. All right. And otherwise, if it's a, let's see, if UI node is a uDialog start graph node, the one we just made, then we'll just set the node type. So runtime node, node type is eDialog node type, start node. And then later when we have an end node, we'll add that here as well. But then likewise, go in the other direction in update editor graph from working assets. So for dialog runtime node, so for each node in the list of nodes, instead of just directly creating it here, start by setting it to null pointer, and then we're going to check what the node type is. So if runtime node type is iDialog node type start node, then we want to create a start node. So new node equals new object, uDialog start graph node, and we'll parent it to the working graph. And then if it's runtime node, node type, eDialog node type, dialog node, and we're going to create a regular dialog graph node. And once again, parent it to the working graph. And if it's not any of those, then as of right now, it's an error. So we're going to do UA log dialog asset editor app sub error text, and we'll give it the function name and unknown node type. So when the editor comes up and we're loading from disk, instead of just creating the old type of dialog node, we're going to check and make the new type of dialog node uDialog start graph node instead. And then when we're loading the information down here, we don't need an info if we're a start node. Start nodes won't have any data, so we'll just do else if runtime node and node type is not equal to eDialog node type start node. So in other words, if we have a node info, we'll just copy it. If we don't, and we're not a start node, then we'll create a new one. All right, so now we'll probably load the start node if it exists on disk, but what happens if we open up a working asset that doesn't have any nodes in it yet at all? And so we need a way to create the default nodes within a graph. And so we're gonna go to the schema, and at the very top, we wanna include the new node type. So include dialog start graph node .h. And in the header file, we want to create a new function. So go to dialog graph schema.h. And right at the top here where it says can create connection, we're going to add another virtual method. We're going to say virtual void create default nodes for graph add graph. And that's going to be a constant override. And we can copy paste that and go to the graph schema CPP file. And we'll put this right above the form action. And so in here, we just want to create the default nodes, which in this case is just the start node. So I'm going to make a U dialog start graph node, start node, and we'll make a new object, U dialog start graph node, and we'll parent it to the graph. And we're going to create a new globally unique identifier for that. So create new GUID, and we'll just start the position start node position X at 0, and likewise we'll set the Y position to 0, so it'll start right in the middle. And then it's going to have one pin, so start node, create dialog pin, E header graph, pin direction, oops, it'll be EGBT output, and the name will be just start. And we'll add that to the graph. So graph.add node, start node, true, and graph.modify so that it shows up as a change. All right, so now we just need to call create default nodes for graph back in the app. We go down to update editor graph from working asset. So if there is no graph on working asset graph, then we want to do working graph, get schema, create default nodes for graph, and we'll give it that working graph, or rather, the reference working graph. And this should create the default start node within our graph so that when we save, that'll get stored into the working asset. And actually, this should be uDialog graph node base now that I look at it. And if there's an error, it should probably continue with the loop. But that should be all we need to do to add a new type of node for the start node. So let's build and run. And now we're back in the editor. If I right click, make an asset, and we open that back up, you see we have a start node. Start node is red. If we add one of the other types of nodes, it's still green. And you can see the pin is red as well. If I save, close that, open it back up, the start node's still there, our connection's still there. And I assume that's the same if we add some text as well. And so there we go. We have two types of nodes now. This one has data that can be modified. If I select the start node, it does not. And this should be persisted to the working asset when we save as well, and it is properly persisted. The next up, we want to be able to create end nodes. And so like the start node, we could just say, well, if there's no outputs on this, then it's an end node. But we also want to be able to do stuff with the end nodes. So like, let's say that at the end of a dialog tree, you want to be able to start a quest, and you might want to start a different quest depending on which chain of the tree you went down or something like that. And so we want to be able to set separate data on end nodes than we have within these dialog nodes. And so let's add a new node type called end node. And let's see, we don't need to save that. And so probably the first thing that we want to do is we want to create a new base class for the node info, because we're going to want different node info depending on which type of node it is. So I'm going to right click on back in our runtime part of the plugin. Let's say new file, dialog node info base. So this will be the base class for the info that's stored on all of our nodes. And so we'll do Frogma once, and the regular boilerplate. And we'll call it U dialog node info base, and it will be a U object. And we actually don't need anything in here except the generated body, because we're going to extend it and put we're going to have completely different properties for the regular node info versus for the new end node info. And so let's go into the existing one, and we're just going to include that class that we just created. So include dialog node info base.h, and we're going to extend from that instead of from uObject. And then we're going to create a new one for dialog endnode info.h. And then in here, and udialog endnode info. And likewise, this is going to extend that new class that we just made for the base class. So dialog node info base.h. And this one will have properties. So we'll have property, edit anywhere. And the first one is going to be the action that we want to do when you hit this particular endnode. So first we need to define what types of actions there are. So we'll do another uenum, and it'll be a blueprint type. And this will be enum class e dialog node action. And we're actually going to make this a uint8 because we want it to be a blueprint type, so it has to be. And there'll only be two options for this tutorial. They'll just be none and start quest. And if it's a start quest, then we're going to have another property that will hold data for this action, and that'll be called action data. And it will be the quest ID in this case. So if you wanted different kinds of data, you could have more different types in the enum here, and action data could mean something different in those cases. There's a lot of other ways you could get data out of this graph as well when it ends, but this is a pretty simple way to do it for this tutorial. And so then we'll use that e dialog node action right here for the action, and it'll just define just default to e dialog node action none by default. And then the other property here is going to be that action data I mentioned, and we'll just make that a string. And it'll default to nothing. And once again, this will just be data that in the event that you make a start quest endnode, you can set this to the name of the quest, or whatever other kind of data you'd want to pass back to the app if that particular node got hit. All right, and I actually have a typo up here, dialog and node info. All right, so now we're going to go to the runtime graph, and down here instead of udialog node info, it's going to be dialog node info base, and we're going to have to include that instead of the regular one. And then just to be organized, I'm going to move the dialog node type enum out of here and put that in its own class as well. And so we'll just include that up here and include dialog node type.h. And I'm going to right click and create a new file, dialog node type.h. And we'll put that enum in there as well as the regular boilerplate. And actually we don't need core minimal, so that should be fine. And we also need we're going to add one more type called unknown, just so we can initialize the node type to that as well. Now, the next thing we want to do is go to dialog graph node base. So this is that class we just made earlier for the start node. And we want to add a little bit of functionality to this. So below our create dialog pin here, we're going to add another virtual method. We're going to return graph pin. We're going to call it create default input pin. So this will give the graph nodes the ability to create their own input pins by default. And likewise, we want a create default output pins. Okay. Now, these methods, we actually want to add one more here. We're going to say void init node info. And this will take a uObject, which will just be the owner of the info. The base class doesn't need to do anything by default, so. But then instead of taking udialog node info, we need to take the base class now instead. So udialog node info base. And likewise, our node info here is going to be a udialog info base instead, because it could be either the endnode info or it could be the regular graph dialog node info. And then we need to include these. So I'm going to include that dialog node type.h because we'll need that later. And I'm going to include dialog node info base.h, which is the new base class for the node info. And actually, by default, we're not even going to have node info in the base class because like start node doesn't have any info at all associated with it. And so we'll just do those. We'll do the storage in the subclass of this. So we'll just put none by default. And likewise for get node info, we'll just return null pointer, and I'll just say none by default here as well. We do want to have another virtual method for saying what your type is. So now that we have 3, instead of having those if blocks, we can just use our inheritance to set what the node types are. So we'll do virtual e dialog node type and get dialog node type. And this will be const. And by default, we'll just use the new type we just defined, e dialog node type. Oops. Unknown. And then when we override, we'll set that to something. And while we're here, later we're going to need another method for virtual void on properties changed, so that each node can update itself as needed, depending on what changed. So nothing to do by default, but we'll need that later. And that should do it for the base class. Although we actually don't need this forward declaration, and all of these methods need to be virtual as well because these will all be implemented by the subclasses. All right, so now we need to implement this on the existing one, or the existing node type. So we're going to go to dialog graph node.h and just paste those methods in here. And let's see, we can put these down towards the bottom. And we actually need to store our info again. So I'm going to add a U property down here. Class U dialog node info. Start that at null pointer. And we'll need to include it. So found include dialog node info.h. Okay. And then, so for these, all the node info related overloads for this one. So init, we just want to create a new one. So new node info, node info equals new object. And the type is U dialog node info. And we're going to give it the outer that gets passed in. And then for set node info, we're just going to set node info to the cast U dialog node info of the passed in node info. And then for get, we just return whatever node info we have. Now back up here for on properties changed. The dialog node, we have those output pins that need to get synced. So we were calling this directly, but we should call this, we should use the overridden method in our app so that we can support multiple different node types. So we'll just call sync pins with responses there. And then for get dialog node type, we just want to return dialog node. That one. And for all of these, we're overriding, so we want all of these to be marked override. And because this is going to return the base now, I'm just going to make a helper method to return the correctly casted version for this. So just udialog node info, and this will be called get dialog node info instead, just so we don't have to cast within our own class here. And that'll just return node info as well. So now we can go to dialog graph node.cpp, and we want to implement these two. And actually, we don't want the default implementations here. So copy paste those and go to dialog graph node.cpp. And actually right below create dialog pin, we can put them right here. So for create default input pin for the regular dialog node, we're just going to return create dialog pin and editor graph pin direction ggpd input text display. So for create default output pins, if you remember back in the schema, this is where the previous default ones were being created. And so we're just going to move this essentially into our create default output pins function so that we can have a more generic call here. And likewise for input pin, we're going to do the same thing. So instead of equals create dialog pin, it's just going to be result create default input pin and result create default output pins. And then we can change, instead of uDialog graph node here, we can say uDialog graph node base. And instead of the subclass here, we'll do the base class as well. And new object, you can pass in the class to actually use. So let's make a member called class template within our fNewNode action here so that we can reuse it for creating the end node. And if I go up here in dialog graph schema.h, I can make a new protected member. So uClass class template equals null pointer. And then in the constructor for this, I'm just going to pass the class to actually create in. So uClass class template. And I can initialize the member down here as well. So class template, class template. So that'll set this up. And now back in the CPP file for graph schema, for graph schema. So we're passing that class template in, but when we make our new node actions, we have to tell it what the class template is. And that's what we just added to the constructor. And so now we're going to have two different kinds of modes, or nodes rather, that you can create in the context menu. So you can create the existing one, the dialog node. So we can do dialog graph node or uDialog graph node, static class. And instead of new node, we'll do new dialog node. Makes a new dialog node. And then we actually want to copy paste this. And we're going to make a new end node as well. So we haven't created this yet, but we're going to do uDialog endGraph node, static class, and it will make a new dialog end node, or well, just end node. It's a new end node. And then in our context menu builder here, instead of new node action, it'll be new end node action. And we'll add that one as well. So now our context menu will have two types of nodes. One will be the regular dialog node that we already had, and one will be a new end node that we haven't created yet. And speaking of uDialog endGraph node, we need to actually make now. And so if I go over to public here, I'm going to right click new file, dialog graph endnode.h. Actually, I'm going to call it dialog endGraph node.h. And then in here, we probably just want to start from our base graph node. So I'll just copy paste all the methods that we're going to need in here and just change the names. So instead of uDialog graph node base, it's uDialog endGraph node. And this extends base class, or uDialog graph node base. And the generated file is this one instead. And we need to include dialog graph node base.h as well. And we're going to need dialog node type. So that's all good. And then we're going to want to override all these methods. So create dialog pin is a method to create dialog pins from the end node. create default input pin. We're going to need to implement that. And same thing with create default output pins. So basically just put override on everything. So for init node info, we'll override that. And for the end node, we do node info equals new object u dialog end node info. And we'll give it the outer that gets passed in. And for set node info, once again, we're going to make our own down here. So protected u property. And we'll forward declare u dialog end node info equals null pointer. And for setting it, we'll do node info equals the cast in one cast to R type. Oops. Cast u dialog end node info. So end nodes will have their own end node info data. And then for get node info, we'll just return node info. And all these are overrides as well. And for get dialog node type, this should just return end. And on properties changed, we don't need to update anything specifically, but we do want to make sure that the object shows up as modified so that the little star will appear and it'll ask if you want to save the graph before closing. And this is a node, and this isn't our interface. This is the base classes interface. And speaking of, we want to implement the regular methods for custom graph nodes. So I'm going to add another section here for the u editor graph node interface. And I'll just go to the existing graph node and we'll steal that. So do we want context menu actions? Yeah, we want the delete menu actions, so we'll take that. But yeah, we'll just copy all of the existing ones over from the regular graph node. And for get node title color, we need, let's just do fcolor blue to be different. Node title will implement in the C++ or the CPP file. Can delete node is true. And we need context menu actions as well. So that all looks good. So head over back. We'll make a CPP file for this now. So new file, dialogNgraphNode.cpp, and include dialogNgraphNode.h. And in the CPP file, we need to implement the pretty much all those methods. So we'll start with the node title one. So we can copy the signature from the header file. So let's see, we need node title and the context menu. So why don't I just copy all this stuff and we'll implement them all one at a time. So for get node title, we're going to do a similar thing to what we did in the other graph node, but for the dialog node, but this time we're going to be using a combination of the action to do and what it's set to. So first just check if we have any node info. So if node info is not equal to null pointer, and if node info action is not equal to e dialog node action none. And so if we don't have any node info, or if our action's none, actually we don't even need an else here. We can return ftext from string text, and we'll just make the title say end at the top for end nodes if we don't have any info or if the node action's none. And otherwise, we're going to build a string. So fstring result equals, and we'll start it at uenum. It's actually a nice method on uenums for getting the name of them. So get display value as text and node info action toString. And then we'll say if not node info, action data is empty. So if there's action data associated with it, and we'll add that on. So f string action data equals node info action data. And likewise with the other node data, if the length of it, so action data.len is greater than 15, we're going to truncate it. So action data equals action data.left 15 plus an ellipsis. And then we'll add to our result. So result plus equals text and action data. Basically, if they pick quest from the dropdown, it's going to say quest and then a dash and then the name of the quest, or at least the first 15 characters of the name of the quest. And then we'll return the result. So return results. Although we got to convert to an f text, so f text from string result. All right, so if there is no data associated with the action, then we're just going to return the action type. But as soon as you add data to it, it will display that in the title as well. So that should look pretty good. All right. So now in the context menu actions, I'm going to go to dialog graph node context menu actions and just copy paste this. So we'll start from that. So instead of dialog node actions, we'll say end node actions. And instead of add pin entry, we'll say delete. And we'll say delete node. Deletes the node. So the only thing in the context menu that will show up for delete node is going to, or for the end node rather, is going to be to delete it. So you can't add or remove pins from end nodes. All you can do is delete them. And then for the icon, we'll do dialog asset editor style. This is the same as before. And then we'll do dialog asset editor node delete node icon. And then create lambda node. And we're going to do node get graph remove node. So just remove the node when this gets clicked. And that should be all we need for the context menu. So then for the create dialog pin, this will once again be very similar. We're just going to do fname category equals text inputs, fname subcategory equals text end pin, and then new editor graph pin equals create pin, and we'll give it the direction, we'll give it the category and the name, and then we'll set pin type dot pin subcategory, just like the other one, to the subcategory, and that'll enable us to color it. And we'll return the pin, and we'll do the coloring in a moment. So then for the default input and output pins, we don't have any output pins, so we actually don't even need to implement that here. I can go back to the header file, and under create default output pins override, we'll just implement it right here. As we don't need to create any output pins, this is the end node. And then the only input pin is just going to be the finished one. So we're going to say return create dialog pin e editor graph pin direction egpd input, and the name will just say finish. Oh, and this needs to be a udialog ngraph node. And if I go back to the header file, let's see, I actually don't need this at all since it's already defined in the base class. And this should be const override, and this should be const override. And I also need to include the udialog, let's see, this udialog endnode info needs to be included. So include dialog info.h. And let me just check that ugraph node or dialog graph node.h is also correct. And looks like, well, this should actually probably be outer, not output. And I don't need to forward declare class there since we included it above. And these should be const. But that should do it. So now we want to make sure that our ngraph node pins look the same as all the other ones. So we can go to DialogAsset editor, and once again, we can copy paste one of these graph pins. And instead of sdialog start graph pin, we'll make it sdialog ngraph pin. And then once again, we'll just change the color. So just make this one slightly blue. And then in our dialog pin factory, instead of start pin, we'll do end pin. And this again matches the subcategory that we set. And if it's the end pin, we'll use the end pin slate widget. And once again, this can be any kind of slate widget that you want in order to define what it looks like. So there's a few other things we have to do with the nodes. If I go back to dialog start graph node, we need to add the override so that it can return what type it is. So I'm going to do virtual edialog node type get dialog node type. And this is const override and needs to return edialog node type start node on that one. And actually in dialog graph node base, I don't need the forward declaration here. I can take that out. And I think I should call this outer, not output as well. That's the same typo that I had earlier. I think I also made a mistake in graph schema. I think I have a typo. Yeah, and create default output pins. I have a capital I instead of a lowercase I. So I'll fix those. Oh, and in dialog ngraph node, same thing. This should be outer, not output. And we don't need to forward declare here either because we are including this. So next we're going to go to the app header file, dialog asset editor app.h. And we were, in get selected node, we were returning a udialog graph node. We just need to change this to be the base. And then in the app, if I go to dialog asset editor app, we got to do a few things in here. So first thing we want to do is include dialog ngraph node, which is the new one. And in on node detail view update, properties change. So in before we were syncing the pins with the responses directly, and now we have an on properties changed method to call, since not every node needs to do that. And so when this gets called on the regular dialog node, it will update the pins, but it won't do that for the end node. So then back in update working asset from graph, we're going to change how this logic works a little bit now too to make it a little bit cleaner. So instead of doing class or direct class checks, we can use the new, we can just use the new node type that we added. So I can delete all of these. And instead of UI graph node, I'm going to call it UI dialog node. And then for node info, we're going to duplicate object. And we'll give it the runtime node. And then for the node type, we could just read it off of the dialog node. So UI dialog node, get node type, or get dialog node type. Yeah, get dialog node type. And just make sure that we rename UI graph node to UI dialog node. And I'm just going to switch the order just to make it a little bit neater. Now, if I scroll down to update editor graph from working asset, we're going to take a look at this if block that we made a little bit earlier. We need to add one more type for the end node. So let's do that. So runtime node type is end node. And we're going to make a new uDialog graph end node. And then we'll scroll down to the info initialization that we were doing before, and we're going to change this logic a little bit as well. We're just going to set the node info to what's on the runtime node. And if it's not, then we're actually just going to call the init. So we made that init node info method, and we're going to give it the runtime node as the parent as well. Or actually, we want the new node to be the parent. And then we just have to update some of the old uDialog graph nodes to uDialog graph node bases, just like we did in the header file. So we'll replace these. And likewise down in on graph selection changed, this needs to be a base as well. And if we go back to the schema, we also have to update this set node info. And once again, just use our init function. So we're going to do init node info and give it the result as the parent instead. And again, this is just so that the inheritance can decide what node actually gets created. And if we go back to dialoggraphnode.cpp, there's a few more updates we have to make here. Instead of reading the member directly here, I'm going to do uDialog node info, and we're going to cast to uDialog node info, the node info, and we'll just replace the cast one like so. And if I go down to get node context menu actions, we want to replace all the get node infos with get dialog node infos, which again just gives us the child class instead of the base class. And similarly down in create default input pin, or output pins rather, we want this to be get dialog node info as well as we do here in sync pins with responses. Oh, and I didn't even notice these results shouldn't be there anymore since we moved it to within the class itself. And sorry to keep jumping around, but one more thing to do back in DialogAsset Editor app is there's a few more of these uDialog graph nodes that should be dialog graph node bases. So we're just replacing everything with the base class instead of the child class, since now there could be multiple. So let me just search to make sure there's no more of those. Looks like there's one here as well. So we'll go ahead and replace both of those. And I believe with that, that's all we need to do. So let's build and run. And it looks like I forgot one more thing in dialog graph node. The base or the child class is const, so the thing that it's overriding also needs to be const. So this get node info here in dialog graph node base.h should also be constant, and that should be all we need to do. Let's try again. And I lied. It looks like I forgot to include the end node in the schema. So let's include dialog endGraphNode.h real quick in the uDialog graph schema and go again. All right, so now we're back in our editor. So let's test this out. I can make a new dialog asset and open it up. We have our start node. I can create a regular dialog node, and let's try out our new end nodes. So first of all, they do show up in the context menu here. They are blue and they say finish. And if you look on the right, unlike with the green nodes, which have title and dialog text and responses, I can't change the output pins on the end nodes, but I do have an action and an action data. I can click Start Quest from the dropdown and the title updates. I can give it a quest or quest name, and it adds that into the title as well. And so now we can make some pretty complicated dialog trees with the tool we just made. So you can have it be, you can have multiple outputs if you want. So I can add a few, let's say we have a, do you want to do the thing? And we can have a yes, no answer as an option. And if you hit yes, it starts the quest. And if you hit no, we can have it just end. So you can make arbitrarily sized and complicated trees with this. Some other things you might want to do in the future, or maybe be able to have feedback. So for example, if I do this, it's going to break that start link. And the reason for that is I made the schema break it because the current runtime graph doesn't support multiple links coming into an input. And so that's just because the output or the save file doesn't support that. But if you want to add support for multiple or saving multiple links at a particular node, then you could support feedback as well, because you might actually want at some point in your tree, it feeds back into an earlier part of the conversation or something like that. So for the last part, I'm going to show you how to make a UI and hook it up to one of these dialogue trees so that you can actually step through them with a real UI in a real game. And in preparation for this, I made a little portrait for the person talking, and I made a little bit more complicated graph that we can use as an example for creating our UI. And so the first thing we need to do is make a few UI widgets that we're going to end up using to display to the user. So I'm going to say new widget blueprint. This one will be widget blueprint, new quest overlay. So this will get shown when we're displaying a new quest. And we'll just make a quick UI here. I'll do a canvas panel. And we'll do a vertical box. And I'm going to call this text container. And inside the vertical box, we'll just have some text. So the top will just say new quest. And the bottom will be the actual quest name. And we're going to line up our vertical box to be in the center, so you can anchor it to the center of the canvas. And set the alignment to be 0.5, 0.5. You want it to size to content. And then if you just put 0, 0 for the position, that'll line everything up. And if I go to the text below, you just want to center everything. And I'm going to make this bigger. Let's say 64. Not that big. 64. And I don't know, 36 or so. Maybe too big. Maybe 26, 30. It's probably good enough. And I don't know, let's make the this text yellow, and we'll give it a outline. So black outline and outline size 2. It's probably good. And for the new quest text, we'll just give it like a big drop shadow. So 1010 and shadow color black. So that looks pretty good. And just to be fancy, we can animate it in and out as well. So I'm going to add an animation. We'll just call it the fade animation. I'm going to add a track, and we're just going to animate the text container. And the track we care about is opacity, so render opacity. And we want to fade in, so we're going to start at 0. And then a little bit further in, let's say at 0.4, we're going to be fully visible. So we get a nice fade in effect like that. And then we'll stay faded in for maybe a couple seconds. And we'll set that to 1 as well. And then we'll fade out over maybe 0.75 seconds. So we'll go to 0. So now we have a nice animation. And then we want to play it when we get added to the layout. So I'm going to go to the graph, and I'm going to, under functions over here, I'm going to override initialize. So on initialized, and I'm going to say play animation. And I'm going to get our fade animation and just plug that into the target. And all the other defaults here should be fine. Or sorry, I'm going to plug it into the animation, and all the other defaults here should be fine. So when we display our new quest dialog, it should fade in and fade out. And that should look pretty nice. So that's the first widget that we need. So the second widget that we're going to need is going to be the response button for, so each output on the node is one response, and we're going to display a button for each option. So we're going to name this widget blueprint quest response button, and we can open that up, and we're going to have a button. Button's going to have a border, and the border is going to have some text in it. We're going to go ahead and name the button response button, and we're going to name the text response button text. And now we just need to make it look not completely awful. So let's just set the tint on the button, or on the button itself, to be transparent. And we'll do 0 padding on the button itself. And then for the border, we just want the border to be to just outline the button essentially with a line. So we'll do draw as rounded box. We'll do fixed radius. We'll set the brush color to transparent, and we'll set the outline color to white. And we'll do, let's say, 5 pixel corners, and we'll set the width of the outline to, how does 3 look? Yeah, 3 is probably good. And then for the text, we want to center it, and the default size is probably fine. You can always tweak this however you want, but I think this should look good. And we'll just change the default text to be okay. So we'll save and compile that. And lastly, and most importantly, we're going to make a widget to display the actual dialog text. So widget blueprint, and we'll name this quest dialog UI. And open that up. And we'll go ahead and start with a canvas panel like we did before. And we're going to do 2 borders. So I'll do a border, another border. And we want this to fill the canvas, or rather, not fill it, but be at the bottom. So we'll line that up somewhere around there. And let's see, so if we position it like this and just do 0, 0, so it'll be perfectly lined up. There we go. And so for this border, we just want it to be an outline. And so we're going to do the same thing we did with the other border. We'll go rounded box, fixed radius, and we'll give it white for the border color, and let's say 5 for the width. And then on the inner border, we'll just make it transparent, slightly transparent, with a black color. Oh, and this border, we want to remove the brush color. We'll set the brush color to transparent. And we can go a little darker with this as well. Maybe right around 0.7 is fine. So then in this border, we're going to add a horizontal box. And in that box, we're going to have a vertical box. And another vertical box. So this second one we want to fill, so it'll take up the remaining space. And the first one will size to its content. And inside here, we're going to actually just put an image. So you don't necessarily need to do this, but again, you can make this look like whatever you want. We're just doing a little example here. But I have a little portrait image we can put here. And we'll make it 150 by 150, I guess. And you might want to have like the name of the person underneath that or something. So we'll just put another text box under it and we'll call it Fred. And let's just center this whole thing vertically and this horizontally. So we've got our little portrait character guy that's talking. So now we need the place to put the actual text. So we're going to add another text entry into the vertical box. Click on that and just make it regular and centered. And we'll give it some padding. And then we're going to add a horizontal box. And this is going to be where we put the response buttons. So responses box. And this one, let's see, we want the text box to take up all the available space and this to just wrap its content. So if I put one of those sample buttons that we just made, if we go to user created, I can do WP widget blueprint quest response button. So you can put one in to see what it looks like. And that's fine, but we want it on the right. So we'll just, in the horizontal box, just have it align right. That should look fine. We can add a little padding to that as well. And it looks like in that button, we probably want a little more padding too, so we can do that real quick. Add some padding there. It looks a little bit better. And this is the basic layout that we're going for. So now we just need to make sure everything has a name so we can access it in code. And I'm gonna change the name of this to be, let's say dialog text. And responses box is already named. And I think that's all that we need. You might want to name the image as well, because you'd probably update this based on who's speaking or whatever. But again, it's just an example, so this is probably good enough for now. So we're going to save and compile. Now, in a previous tutorial, I showed you how to generate the controllers for widgets automatically. I'll link that video in the description if you want to check that out. Or you can just go to the Git repo in that video and download the code. But basically, it adds these scripted actions that will automatically create the controllers for each of these classes. So I'm going to right click on New Quest Overlay and I'm going to say Create Controller. And I'm going to make a folder called UI. We'll add this too. And we'll create that. And I'm going to do the same thing for the other two as well. So scripted actions, create controller. Okay. And what that did is it created, if I go to the code, it created a folder called UI and it put a bunch of these controllers in it. And each one of these controllers has access to all of the widgets that were named. So anything that doesn't have the default name, and it has a create instance, so we can easily create these widgets in code and just immediately start working with them without having to write any of this ourselves. And it also, if you go into, if you open one of these back in the widget editor, you can see that the parent class is now new quest overlay controller and not user widget. And so it automatically reparents them after compiling as well. So let's go back to the code. And now what we want to do is make some code that plays back our dialog graph. So basically walk through the nodes, let the user pick an option at each node, and then move to the corresponding next node or end the dialog if is appropriate. And so what we're going to do is create a class called dialog player. So we'll make a dialog player.h and a dialog player.cpp. And as always, add the boilerplate. And we're going to make a class called uDialogPlayer, which will be a uObject. And basically this is going to have just a couple methods. First one's going to be called playDialog. And this is going to need a dialog asset. This is the asset that we're going to play. Needs a player controller so that we can add stuff to the UI. And we're going to give it a function, std function, that takes an eDialog node action and some data. And we'll call that action. And this function will be called onDialogEnded. And so this way we can call back to whoever played the dialogue for when we exit, we can call the function that gets passed in. And I actually forgot a bracket there. And the other method we need is choose option at index. And this method will get called when the user clicks on a button, and it'll choose the option at the index of that button. So we'll implement those in a sec, but we're also going to need a few member variables. So we're going to have a property for the asset. So DialogAsset, and this is the currently playing asset. We'll start at null pointer. And we're going to have a dialog runtime node, which is the current node. So this will represent what text is currently being displayed, essentially. And we're going to have a property for uQuest dialog UI controller. And that'll be null pointer. And then we need to store that function that gets passed in. So we have the callback. So eDialog node action fstring data on dialog ended. So that should be everything we need in the header. So we can move on to the CPP, and we're going to include our dialog player.h, and we're going to implement these methods. All right, so we're going to need a few includes. So we need, we forward declared most of the stuff, so we need to include DialogAsset.h and DialogEndNodeInfo.h. And these are all those runtime classes we made earlier. We're going to need the Quest Dialog UI controller. We're going to need Quest Response Button controller. This is, so these are the controllers that were auto-generated for our UI elements. And we're going to need the text block component. And we're going to need the horizontal box. And we're going to need the horizontal box slot. The first thing we want to do is set our callback method. So we're going to do onDialogEnded equals onDialogEnded. And we're going to get the graph. So uDialog runtime graph. And we get that from the dialog asset that gets passed in. So dialog asset graph. And I want to start by getting the start node. So we're going to iterate over the nodes in the graph. So uDialog runtime node over graph nodes. And if the node type is eDialog node type start node, and we're going to set the current node to that one. And we're going to break. So we can do a quick check just to make sure that we actually found a start node. So if the current node is null pointer, we want to bail. And we should probably log an error when we do that. So define log category static, dialog player sub log all, and then UE log dialog player sub error text no start node in dialog. But if we do have a node, then we want to create and display the dialog UI. So we're going to say, oops, dialog UI equals uQuest dialog UI controller create instance. And this is one of those methods that was generated. And we're going to give it the player controller. Then we're going to say dialog UI add to viewport. And then we're going to use the helper method here, choose option at index. And then we're going to say choose option at index 0. Since there's only one pin on the start node, this will pick the first option and go to the first node on the graph. And now we just have to implement this method, which is where the actual work happens. And so we have the index that we want to move to. So we want to move to the given index if we can. And we're going to check if the index is greater than or equal to the current node's output pins .num, or if it's less than 0. Oops. And if it's less than 0, we want to log and bail again. And we'll just say invalid response option at index %d and give it the index that it was trying to go to. So now we know that we have a valid index. So we're going to say do dialog runtime pin output pin equals current node output pins at index. And if output pin connection is not equal to null pointer, then we're going to set the current node to the output pin connection parent. Now, I actually don't think we ever added a parent, so this would be a useful thing to do. So what I'm going to do is just go back to our runtime graph. And real quick, we're going to add a parent. So in, let's see, udialog runtime pin, right below connection, we're going to add a property. And we're going to say class udialog runtime node parent. Just assume null or default it to null pointer, and this will just point to the node that the pin is a parent of. And then if we go back to our app, the DialogAsset editor app.cpp, and let me just search for where we create the new node, or excuse me, the new pin. And right underneath where we set the pin ID, we can just set the parent. So runtime pin parent equals runtime node. And so now we have the parent. I can go back to our dialog player. And so now that will work as well. Now, if the connection is null pointer, then we just want to set the current node to null. And we'll assume it's an end node if there's no connection. So that way you don't have to put a bunch of arbitrary, or you don't have to put a whole bunch of end nodes where you just want to close the dialog without starting a quest or anything. You can if you want, but it won't hurt not to. So now we want to check if the current node is not null pointer and the current node type is dialog node type dialog node. So this means that it has text and it's not null. We want to get its info. So dialog node info, and we're going to cast dialog node info, current node info. And then we're going to say dialog UI, dialog text, set text, node info, dialog text. So that should set our dialog UI's text to whatever the text on the current node is. And then we want to set the options that they can pick with the buttons. So we'll say dialog UI response box or responses box, clear children, so clear whatever's there. And we want to set the option index. So in option, or keep track of the option index. So we'll start at 0 and we'll say for ftext response in node info dialog responses. And for each one, we'll make a controller. So uQuest response button controller button equals uQuest response button controller create instance. And we'll just get the player controller from the dialog UI. So dialog UI get owning player. That'll create our our button. Now we need a way to get notified when the button gets clicked. So I'm actually going to go into this controller and we're going to add a couple things to it. So in our public methods here, I'm going to add void set click handler. And we're going to give it an index to keep track of, and we're going to give it a function to call when it gets clicked. So the function will give us an int, which will be that index, and it'll be called onClickHandler. And then we need a U function for onButtonClicked. And this is what we'll assign to the delegate. And the reason we're going to have a separate function passed in is because this one can have an argument, this one cannot. And so this button will keep track of what index it is assigned to. And then when the button gets clicked, it's going to pass the index it's assigned to some callback that is set with this set click handler. And we also need to store this index in a variable somewhere. So I'll do a private section down here for int index. And we need to store that function as well. So std function void int on click handler. And we'll need to include functional as well at the top so that we can use std function. There we go. And if I go to the CPP file now, we can implement those functions. Let me just copy and paste these. And we'll put them right in the middle here. So in set click handler, all we have to do is assign our index. So index equals index. On click handler equals on click handler. And we need to assign a delegate to our button. So the generated code automatically created a response button property. We can say on clicked.add unique dynamic and this, and we'll give it the address of our on button clicked method. There we go. And then in our on button click method, all we want to do is if on click handler, just call it. So on click handler and give it the index. So now when our response button is clicked, it's going to call on button clicked, and it's going to call whatever handler was set on us with the index that we were assigned. So that should be all we need to do with the quest response button. And now back in Dialog Player, we can start assigning things to this button. So we can call button set click handler, and we'll give it the current option index, and we'll give it a lambda with the option index. And in here, we're just going to say choose option at index, option index. And so whenever we're at a dialog node and they click a button, it's going to go back into this function to choose the next index. So it's recursive until we get to an end node. And let's finish off this loop. So we want to set the button's text and things. So I'm going to say button response button text, set text to the response, and then U horizontal button slot, box slot rather, slot equals dialog UI responses box, add child to horizontal box, and we're going to add the button. And this method returns the slot so that we can add a little bit of padding around it. So I'm going to say slot set padding f margin 10, just so there's a little spacing around the buttons. And lastly, increment the index, so option index plus plus, so we go through the rest of them. So this will go ahead and add a button for each one of the output options on our current node. And now for this, for the if statement up here, we checked if the node wasn't null and we're a dialog node. So now else, meaning either the node is null or it's not a dialog node, so it's a end node essentially. So we're going to get the player controller. So a player controller equals dialog UI get owning player. And we're going to say dialog UI remove from parent dialog UI equals null pointer. since this is an end node. And then we want to check what type of end node it is if the current node isn't null. So first we're going to say D or E dialog node action equals E dialog node action none. And then we're going to have a variable for the action data that's passed along with it. So action data equals text. We started at blank. And we're going to say if the current node is not null pointer, then uDialog endNode info, endNode info equals cast uDialog endNode info, and we'll get the node info from the current node. So current node info. And then we can set the action to endNode info action, and we can set the action data to endNode info action data. And then otherwise, we're just going to use the default no action and no action data, which will just hide the dialog from the parent and won't do anything else. But we can call our callback now on dialog ended, give it the action and the action data. And that is all this function needs to do. So essentially we're going to come in here. If we're a dialog node, we're going to display a button for each choice that the user has. And we're also going to set the text to what's inside the node's dialog text. And if we're an end node, we're going to grab the action from within the end node info. Unless the current node is null, meaning we just ran off the end of the graph. And then we're just going to call on dialog ended with none and no action data. So I'm going to make a few corrections here. So this doesn't need to be forward declared. And looks like I have a lowercase n instead of an uppercase n there. And this should be current node, not current. And I missed closing bracket there. Oh, and I'm missing a bracket closing this for loop as well. Means I have an extra one as well down here. Just fix that spacing. And we actually want an else if here, because we also want to check that parent node is null pointer or current node type is an end node. And we also need an equal sign here. So that should be all of the changes needed for the dialog player. And so now we can actually use the dialog player with a player controller in order to read one of our dialog graphs. So first thing we need to do is go to our test player controller.h. We're going to add a few properties in here. So add a protected section, new property. So we want a uDialogAsset. So this is going to be what we're playing. And we want a uDialog player. This is what we just wrote. That will play through our asset. And lastly, we want a uNew quest overlay controller. And this is if they start a quest, how we'll display the new quest that they're starting. So new quest overlay. And then if we go to the CPP file, we can do everything pretty much we want to do in begin play, but we also need to load our asset. So I'm going to do static constructor helpers f object finder. And we want to find uDialog assets. And we need to include that. And while we're up here, we're going to need a few more things as well. We're going to need the endNode info. We're going to need the UI controller. So UI new quest overlay controller. And we're going to need the dialog player. So UI dialog player. And we're also going to need to be able to use the text block when we're displaying the new quest. So textblock.h. That should be all the includes we need. And then back to the constructor. We're going to make a dialog asset finder. And the path is /game/ and I just called it the beginning quest dialog as a just an example asset that we can play. So if DialogAsset finder.succeeded, DialogAsset equals DialogAsset finder.object. And if not, we should probably log that it couldn't find it. So test player controller sub error text could not load content. All right. So now in begin play, we just need to use our stuff. So first let's create a dialog player. So dialog player equals new object, new dialog player, and this is the parent. And now dialog player play dialog, and we got to give it the asset to play. Got to give it the player controller, which is this, and we have to give it a callback when the dialog is over. So dialog node action f-string action data, and make a lambda. So we're just going to check if the action is an dialog node action start quest, and if we already have an overlay, so new quest overlay is not equal to null pointer, and hide it. So new quest overlay, remove from parent. And by the way, we made it so that this fades out after a few seconds, so it doesn't matter if we leave it up, it'll just be invisible. But if we have a previous one, we should remove it from the layout before we create a new one. So remove that from the layout if there is one, and now we're going to create a new quest overlay. And we're going to set it to new quest overlay controller, create instance, give it this, a new quest overlay quest name text, and we'll do set text, f text, from string action data, and new quest overlay, add to viewport. Now, I think I don't think I named the quest name. Let me check the controller. Yeah, we just have the text container, so we got to go in there and make this real quick. So let me comment out that, and we'll build and run. Oh, and dialog player needs to inherit from uObject, not object. And I didn't end this function declaration. And this needs to be a pointer. And if we go back into our quest overlay widget blueprint, all we need to do is rename the name of the quest. So we'll just give it the same name, quest name text that's in the code. There we go. I'm going to save and compile. And the nice thing is I can right click and I can do script asset actions update controller, and that'll automatically update the code. And so if I go back to the code, new quest overlay controller, you can see we now have a quest name text block automatically added. And so now I can uncomment this new quest overlay quest name text, and that should work just fine. So let's build and run, and everything should be all set. Now before we start, I'm just going to go to Window World Settings and make sure that you have the test player controller actually set. So I'm going to select BP game mode, which is right here. And then in here, I'm going to make sure that that test player controller is set, and it is. And so it'll actually use the player controller that we just added that code to. So if I hit run, you can see it says, "Greetings traveler, what brings you out this far?" We've got our little icon, we've got our we've got our buttons on the bottom right. So if I click on a button, it goes to the next thing in the chain. And if I hit no here, it'll close it because that's an end node. So if I start again and I don't hit no, it continues on with the chain. And if I keep going and I accept the quest, you see a new quest comes up. and fades out. And likewise, I can go the other way. I can say I live for adventure, and you can say go kill 20 boars, and now it says beginning adventure on the quest instead. There we go. That's the end of this tutorial. Sorry it got a little bit long, but I think it is a pretty good end-to-end description of how to actually use all these editor tools to do something useful. And you can certainly use this for a lot more than just quest dialogues or dialogue trees, but it's a good example to show how to actually use this stuff at runtime. So thanks for watching, everyone. If you like the content, feel free to like and subscribe. I'd really appreciate it. All the code, as usual, will be in the video description, as well as the links to the previous videos that this one's based off of, and also that controller generator plugin that I was using to generate the code for the widgets. That'll be linked in the description as well. And yeah, if you have any questions or comments, just ask them down below, and I will answer them if I know how. So thanks, everyone. Have a good one.